Hi, this is Pat Lyons from PGL Surveys, and what I'm going to do is hopefully demonstrate what I think is a very good idea on checking a slab doesn't have puddles in it. And the video is a bit intended for people that are learning or training to be engineers and achieved an ability, and they suddenly think to themselves that there's better ways of doing some of the work that you do that maybe aren't normal procedures. So what we have here on the ground, we have a Geomax instrument. I'm hiring this instrument and I'm paying £50 a week for it, and it's great, but I don't consider this level of instrument that costs, say, in the £5,000 bracket as the ideal tool for a job like this. So what I've got here is I've got my own instrument that the reason I'm hiring the other instrument is so that this thing doesn't have to work in the rain. I basically treasure it and I rely on it. So let's see. This instrument is Leica TCRA1103 Plus. First thing I'm going to do, I'm going to level the instrument. So I press a button on here and there's my bubble, and hopefully I can get that somewhere near the middle. So nothing dramatic so far. Now then, the advantage of this sort of status of an instrument, you're looking at top quality instruments that they can check themselves before they do the work. So for example, what I'm going to do on this instrument here now is I'm going to check whether it's within the accuracy that is suitable to work. So in order to do that, I got instrument calibration. Now this instrument will do this on its own accord, whereas this machine on the ground will be the same calibration as it was last time it went through the higher process. Okay, so this is this machine doing it. The first thing we're going to do is go to instrument calibration, and we're going to check the spirit level bubbles on it. The last time I checked it in the office, it was 2 seconds and 9 seconds correction in the compensator, longitudinal and transitional. So what I'm going to do now is I'm going to do a quick check on it. Alright, so here we go. And what you will see now is the instrument is going to start working out the answers itself. This sort of behaviour is typical of any instrument costing 15,000 and above. And something like this machine, like a TCRA1103, probably is a 20,000 plus machine. Right, so what we got a reading of 6 and 9, and I think we had 2 and 8 before. So okay, I will accept the new values as though these are right. Okay, let's just check again. 6 and 9 is what it's asking. I'll say no, and 2 and 9 is what it's saying it was before. So really there's no effect on 1, and the 2 is suddenly becoming the 6. So let me just check my bubble is good for level before I do any adjustment. I'm going to go here and check my spirit level bubble, and that now is pretty bang on. That's about as bang on as you'll get. Okay, so let's continue. Go back and do that check again, instrument calibration, and the instrument is now working this out. So the idea of things is that we get this concrete floor here perfectly flat, and we don't, for example, have one area where it's sort of 5 mil low, very close to an area which is 5 mil high, which then facilitates a bubble that is that facilitates a puddle that is 10 mil deep. So what we got here on the instrument now, going back again, is 5 seconds and 9 seconds. So I'm going to accept them new values, okay? And right, okay, they're accepted. Now then, what I'm going to do with the machine is I could go on testing it all day. I've only added that part of the test just to show that the instrument has got this facility and it's not on your cheaper instruments. Hence, I think this type of work is only good for instruments of this sort of quality and standard. Right, okay. So what I want to do now is use a program called Free Station, and there's my Free Station. Okay, so I'm going to go on there. I'm going to call it 999, which is basically, I don't know anything about it, so it'll be 999. That's where this machine is. X, Y and Z is going to be stored for this machine, and its location, it's always going to be called 999. Basically, anything that says 999, I don't ever have to keep records of it. It's just random setups. So I now have got a site, the survey station. Well, on my screen it says ZLTB, and ZLTB is where, actually means it's Z for this type of work that I'm doing. L means little, and T and B means little trolley bay. So I'm hoping now I can see that, and basically if I do see it, there's no pogo height, and I also got to be on a reflectorless prism, and that sign's reflector, so I change that to reflectorless, and here I go. So let's see if we can see the target. Be handy if I check that first before setting up. Yeah, good news is I can see the target. Okay, so at a distance of about 150 meters away, I've got a target which is a reflective target. I'm going to search now on the instrument menu for that target, and it's actually saying there's no points with ZLTB in it. That's very strange. So if I view it, bit of an issue here. ZLT, is that a B or a D? Okay, I had LTD, LTB, so we got the coordinates of what that station is on here, and we got the level. That's the X, Y and Z of that station. So I'm going to say that, yeah, you are on the right point. I'm going to view it again through the telescope, and now I'm going to get a distance measurement to it. Now we can see that 113 meters, 274 away, I've taken that reading. So I'm going to record it, and I'm going to move on to the next reading. Now the next reading is a totally different direction, and the station of the other point is L, and it's LBCR, which is B for blue, C for cabin, and R for right, meaning the right window. So I'm going to now look at that station. Okay, I'm now looking at that station, and if there was some way of showing you through the eyepiece, I don't know if I can get that done. Well, basically that's the eyepiece, and you can probably see it in the distance, but it's not very good. Anyway, so what I'm going to do now is I'm going to search for that station, and it's found that station. So what I'm going to do now is measure the distance to it. So on my instrument, I've now found that 94 meters 703 is the distance to that station. The bottom line now is this instrument is clever enough with a program on it to compute where it is from two fixed points. So if those 2 points were exactly to the millimeter in the places they were supposed to be, and everything was in perfect order, this instrument calibrates where it is exactly. Problem is, in life you've got expansion, contraction all day long, and things will vary, and you also got instrument errors. So it could be that I could be a few mil out. In fact, 5 mil would be fairly good by all accounts. But I generally find with this instrument, I want to be working to 1 millimeter in every direction. So let's see if I could achieve that. So I've now recorded that. Okay, now the instrument now tells me I can calculate where I am. So I'm going to calculate where I am, and the instrument has straight away calculated where it is here. Now we're going to see how good that calculation is. and there's things called the residuals. So I've got 3mm, 3mm and 2mm. So effectively the position is going to be that I'm going to be surveying is within 3mm X and Y is going to be quite good, but I'm not really interested in that. I'm interested in the level, and the accuracy of level I'm likely to achieve is 2mm. So I can now say that this is really good, and I've got the ability to move on. Okay, so I've stored and I've set that. Right, so the machine now is going to act as a very accurate level, and that is what's needed on this job here. As you see, there's a guy, we've just poured a floor, and this guy's task is to get this floor to a really glass finish and really good for level. Now, so far they've used a rotating laser and a survey staff, and they believe that's quite good. The actual level of the floor is supposed to be 53.5 meters, okay? So what I'm going to do now is I'm going to set my instrument to measure, and I have no idea what the answer is going to be, but all I'm interested in is the elevation, the level, which is the bottom reading. So I press distance, and for the point where the laser's hitting now, I've got 53.503. So that's good in the fact that that part of the floor is 3mm high. Okay, what we don't want is 10mm high, and what we don't want is 10mm low. So if everything goes to plan and we're within a real low tolerance, it means that when this floor has been finished pouring and a couple of days down the road it rains, what we won't find is bad puddles there, because for sure big puddles are going to show that our work hasn't achieved the best standard going. So this method is above and beyond what is normal for this type of work. So I'm going to start up on the top left, and I'm going to take a reading up here. Let's see what we got. $53,499, so that's 1mm low, which is excellent. Better than I would expect. Go into the middle. 53,514. So we've got a point there that is 14mm high. Now that would be of concern to me, and I'd want to get that off. I want to remove 14mm there, or some of it, so that we don't get a puddle. Anyway, let's survey it first. I go along another part of the far end. And here I've got 53,514. So it does look to me that that one section of it is a bit high. So we carry on and just taking note of where things are. Now that's 53,499 again, which is very good. And I got a 53,505, which is just a shade high. We wouldn't worry about 5mm high. So let's hope that area is a bit isolated. This area is 53,506, so 6mm high. That's quite okay. And we got 53,504, looking good. A 53,499, good. A 53,498, which is good. This can often be stored on a CAD drawing, but on a small, and you can give the guys a CAD sketch. But on a small site like this, no need to. Now here we have 53,494, which is 6mm low. I'm not totally concerned about that. That's about the limit I'd take. And 53,498. Okay, 53,578. Something's wrong there. I've hit something that I shouldn't be hitting. it's part of the shutter. So I got 53506 with 6mm high. .53503, that's excellent. Back onto that, 53503 again in the level, which is excellent. And a final reading of 53501. So what we have now is a section where I've isolated a small area, which I would imagine is from the middle of the slab here, the slab being, let's say it's 7 meters wide, it's about 3.5 meters of it, and I would imagine that from the door that you can see it's probably about 3.5 meters out. So technically what we need to do is go into that area very carefully and take off about 10mm of the concrete, and in that way what will happen is that we don't end up with a high spot, and generally our floor finish is within an exceptionally good tolerance of what it would be expected. This is above and beyond what you'd normally see on a site. Normally somebody would have completed the work as it is to now with a rotating laser and relied totally on the ability of the rotating laser, which to all intents and purposes does give a good finish. But if we really want to be exact and we don't want puddles here, we will have puddles when it rains, but we don't want deep puddles. If we take that area off here, it will show a good job has been done. Right, some final things about this now, being a little bit that is the video is intended for other engineers. One of the things is I'm using a reflectorless instrument, and I've got a lot of confidence in the reflectorless instrument because it's a good quality bit of kit. It's made by Leica, and there it is. It's a Leica TCRA1103. The instrument then, as you can see by the badge, has been serviced and calibrated by a company called A1 Survey in Cardiff. They're a decent company, a good company, and the point here is not to lay on about the abilities and things like this, but as you saw at the start of this job, I managed to calibrate the machine using the onboard software on the machine. So when it comes to getting a certificate like this one from A1 Survey, which was done in August this year, March this year rather, I don't believe there's any sense in sending away to get a calibration QA certificate, because you're just getting a certificate for something you can do yourself anyway and see on the machine. What I believe is if you've got good kit, there's no calibration is one thing, but actually servicing the machine so that it's been cleaned, adjusted, oiled, defungused, etc., and it's in the best, it comes back to you in a better condition than it went away. It means that the machine is not only in calibration, but it's better able to do its job. You know, it's like if you're going to look after your car, you're going to do all the checks on it, so that never mind whether it passes MOT, you're going to want to know that every bit is running properly. And that is important, more important with the machine. I would never technically send my favourite machine away for a calibration. I'd only send it away for a service, so something is done to make it better. Another thing that people that use Leica machines and some of these expensive machines, you'll notice I got a battery on there. Now that battery will last probably a week. You could have bought that battery in 1978, and that battery with the right cable to that machine would power up every single Leica instrument to date. And what is happening more and more today is people are spending £150 on a little battery that goes in here, and it fits into this little box, and it goes in here, and although it makes things smaller, you spend £150, that lasts 2 hours, and another one lasts 2 hours, and bit by bit, every day during your work, you're being brought down by your batteries running out. These are very high battery use instruments. So by having this instrument battery on it, I'm confident that it can not only power every single Leica instrument I've got, whereas the battery that goes in the side here will only power this model, and as they do with everything, they make the batteries to power the latest model. By having this, when I buy a Leica machine, I don't ever buy the batteries again, because what's the point? I've got the batteries already, right? So that's a good thing for some people who get frustrated with batteries not lasting. Buy you one battery that powers all your machines, and it might be clumsier and heavier, but in a lot of ways I think this does a better job. Right, so here we are. We've now got a situation where this site has had a concrete pour surveyed, and what we've got to try to do now is get that so that it's good for level. So I'm going to get the man to deal with it. Let me see, we've got the two concrete guys here, and these guys are busy, so we won't stop them. I'll go and speak to this guy who seems to be their boss, and we'll see where we go from here. So lads, can I just interrupt you to speak to this man by here? Can I just show you some things about the pour by here?
Yeah.
Okay. What I've done, I've scanned the level of the surface of that concrete pour for you, right?
Yeah.
And it's exceptionally good, right? And what it is, everything on 2/3 of it is all within 5 mil, okay?
Yeah, 5 mil.
So we're not going to worry about it, right? Now by here, even though it's within good tolerance, what I see is just say the right hand side of the pour there, and for about 3 meters in,
Yeah.
I believe it's about 14 mil.